My name is Elijah Meeks. I live in the Bay Area. When I was working on the ORBIS project, I was the Digital Humanities Specialist and then later the lead developer for the Center for Interdisciplinary Digital Research at Stanford University Library. My areas of specialty are GIS, web mapping, network analysis, and the production of interactive scholarly publications. ORBIS is the Stanford Geospatial Network Model of the Roman world. It was designed to simulate the transportation of goods and the movement of people in the Roman world, broadly speaking. The Roman world as it was maximally extent. It was never the size that it was as simulated in the model. It achieves that by simulating land travel and the cost of shipping goods on land or on river or on sea according to Diocletian's edict. Sea travel speeds are based on simulated sea travel. Movement speeds on rivers are based on schematic rates of travel on the rivers. ORBIS was implemented to better understand the movement of peoples and therefore the shape of the Roman world in the eyes of historical actors. So we think of state systems to be the kinds of modern state systems that we look at on maps that are built on modern understandings of space and geography. And we understand territory in a way that early peoples didn't. Early peoples understood a territory that they were embedded in, that was the shape of the world that they were in was based on priority, it was based on time of year, it was based on their location within a network. So ORBIS reflects this in that certain parts of the network are more or less accessible based on time of year. They're more or less accessible based on whether or not you're trying to move people there or ship goods there. They're more or less accessible based on whether you are starting out in one part of the system and trying to get to a different part of the system, as opposed to starting out at the center of the system and trying to get to perhaps one of the semi-periphery areas. ORBIS is one of the most robust web mapping applications available right now because it takes advantage of exotic geospatial information visualization techniques that you don't typically see deployed in web maps, like Voronoi tessellation or dynamic distance cartograms. ORBIS is also unique in that it's been extremely popular not only in the scholarly community and not only in the classics and historical community, but also in other scholarly communities. It's been used by climate scientists to better understand climate change during the Roman period, and it's also been very popular among the public. ORBIS has been featured in articles in traditional print publications, and it's also been featured on popular internet websites like Ars Technica and Reddit. To query the ORBIS model, you access the online mapping interface, and depending on the level of resolution of your query, you might select the Route tab, the Network tab, or the Flow tab. To explore the cost in time or money to move from one location to another in the ORBIS model, in the Route tab, you simply select a single location in the From field and another location in the To field and click Calculate Route. Here we can see the fastest route from London to Rome. We could contrast that with the cheapest route from London to Rome, which emphasizes the incredible difference in the cost to ship goods overseas as compared to shipping goods over land. We could also change the time of year, either via season or specific month, to access the changes in wind conditions and sea travel availability based on heavy seas that the model simulates, and calculate a new route. And we'll see that there is a different, cheapest route between London and Rome during the winter than there is during the summer. By exploring routes in this way, you can explore the contingent relationship between 2 points in the ORBIS system and therefore 2 points in the Roman world system. You can see how London, due to its access to coastal shipping, is during the summer part of the connected Roman core, but during the winter much farther away from the Roman center than other sites in the Mediterranean that might be less far in traditional as the crow flies distance. If you're interested in the effect of different times of year and different priorities and different perspectives on the shape of the Roman world, then you can use the network queries by clicking on the network tab, and instead of selecting a source and a target for a route, you select a center. You could select Rome, and as with the routes, you select a priority. You can select a direction of the travel. You can turn on or off certain network options, and then calculate the network distance for the entire ORBIS model from a particular or to a particular center. Here we can see the cost in time from Rome to the rest of the Roman world. We can represent that either by coloring the paths to reflect the cost, or by leveraging Voronoi polygons to represent that cost as a territory, or by utilizing distance cartograms to distort the Roman network to reflect the cost based on the actual measured straight line distance from Rome to various sites. A distance cartogram maintains the angle of a point, or the points that make up the routes that are represented using geospatial data objects like polylines, while distorting the distance. So Tarraco, for instance, is the same angle from Rome, but its distance now reflects its relative time network cost to reach Tarraco from Rome. Because we're able to measure the distance from or to any sites in the Roman world to a particular center, because we're able to calculate those centers, and because we're able to calculate multiple centers, then ORBIS can leverage this capability to split the Roman world into clusters based on the distance from a site to a particular center in the calculations that you've run. That clustering also includes a frontier tolerance, so that you can designate any sites that if the cost to reach one of these centers is very close to the cost to reach another center, it's within that tolerance setting, then those sites will be labeled as frontier regions. The clustering results color the sites based on the nearest center, or whether they're in a frontier region. We can also use the same zones feature to show those regions territorially. So here we see the Roman world split into sites that are closer to Rome, Constantinople, Jerusalem, or London, closer defined by our query as being in the cost to ship kilogram of wheat in the summer, as well as sites in a dark blue that are within a similar cost to reach 2 or more centers. ORBIS also provides the capacity to export the results of your work as SVG or as high-resolution PNG of the various network diagrams and flows and routes that you might have calculated. The interactive interface into the ORBIS model can be accessed at orbis.stanford.edu. Static snapshots of the model can also be downloaded from the Stanford Digital Repository. I hope you enjoy using ORBIS, whether you're trying to further understand the movement of peoples in the classical world, or you're just using it for fun.